Hi, everyone, and thank you for joining us today. I'm Emily. I'm a developer advocate from RisingWave, and today our webinar will be focused on the integration between StreamNative and RisingWave. And from StreamNative, we have David joining us. So why don't we go ahead and I'll go ahead and share my screen and get started. So David, why don't you go ahead and start with your self introduction.
Yep. Thank you for that, Emily. Hi, my name is David Kjerrumgaard. I'm also a developer advocate, but I work for StreamNative. I'm an Apache Pulsar committer and worked previously at Splunk and other large systems, FedEx, Amazon, all the different logos shown there. And I'm here today to show you how to get StreamNative up and running on the platform and integrate it with RisingWave. So thank you all, and hopefully you enjoy the webinar.
Yeah, so a little bit more information on today's webinar. We'll be diving into a topic that's becoming more essential in our data-driven world, and that's going to be real-time data processing and its power. So keeping up with like a never-ending stream of data is not very easy. Things change by the second, and it's nearly impossible for traditional data processing systems to keep pace. That's where stream processing comes into play. And unlike batch processing, stream processing allows businesses to analyze data as it's being generated, allowing you to derive insights in real time. So for instance, social media platforms like Instagram, X, or Twitter are flooded with countless messages, posts, interactions every single second. And there's a lot of information that you can comb through in that. So for certain companies, analyzing these interactions in real time offers a unique opportunity to understand consumer behavior, track emerging trends, and gain a competitive edge. So today, we'll show you how to set up a real-time streaming pipeline that can handle these challenges. We'll use a data generator to send fake tweets to a StreamNative cloud cluster and ingest that into RisingWave to process and analyze data. So we'll walk you through the entire process, starting from setting up a StreamNative cluster. And David's going to tell you guys a little bit more about what StreamNative is and how to get started.
Yeah, thank you for that. So in the slide shown there, there's a self-paced course after this webinar if you want to go to that URL to walk you through a more self-paced getting started on StreamNative and working specifically with the Kafka protocol. But StreamNative, taking a step back, StreamNative is a company around that offers a Kafka compatible and a Pulsar-based stable, scalable streaming data service that's at its core is based on the Apache Pulsar project that came out of Yahoo in 2012. It is also fully compatible with the Kafka API. And we at StreamNative deliver it as a fully managed service that incorporates a lot of different features that make it and tooling that make it much more easier to use and take a lot of the complexity out of managing the cluster. Next, I will go ahead and walk you through the steps required to create a cluster on StreamNative Cloud, which is available for free. You get $200 free credit if you sign up today or at any time. Come into the website, you'll be able to play with the UI that I'm about to walk you through. With that, I'll go ahead and share my screen if you don't mind. So I will share my There we go. So hopefully you can see the StreamNative website. So if you go just to streamnative.io, our public website, you should be able to come into this page, get a lot of information and product, details, etc. Documentation is all available if you want to learn it or follow up on some things. But to get started, you go ahead and log in as the first thing you do. You can either create a new email address, you can register if you're brand new. That would be the process. You come in and sign up. We also integrate with your Google commands. Since I'm already signed up, I will use my Google account, my StreamNative account, that you would come in to the console. Hopefully it comes up here quickly. Coming into the StreamNative cloud. There we go. Now, initially you would create a different organization, but obviously as a member of StreamNative, I belong to several organizations. But your experience would come in for the first time. and you were to sign up, you landed a screen similar to this, or I created this organization for this demo. As you can see, it show you, how much of my $200 credit is remaining. I've yet to use anything because I've not spun up or created an instance, which is how you get started. Right now, you just have a console. You have access to a console, but you have nothing to do, nothing with it. So first thing you would want to do is create an instance. Now you have different options when you're creating instances depending on what your requirements are. You have serverless, which is a pay as you go, starts at $0 a month, is our completely serverless one. It's a shared resource model. You can come in based on your throughput, your charge only, and you're only charged for what you use per hour. Once you're done using that, it scales down to 0 and your billing stops. You can also have a dedicated cluster, which is infrastructure spun up within StreamNative's account itself. That it gives you the fully managed cluster, a more guaranteed quality of service and latency because you have dedicated resources for your brokers and bookies, all of your different storage. It gives you also stronger isolation, right? So unlike a shared serverless cluster, your data is never commingled with anybody else. So if you want to use sensitive data, definitely use dedicated or the BYOC option, which is bring your own cloud. We offer our StreamNative solution as a fully managed solution within your own cloud environment. Everything is deployed within your cloud account. Access is limited to you. Allows you to access the console and your Kafka brokers directly over a local network connection, saving you a significant amount of cost. And these are different options on that. So we'll go ahead. For this, I would recommend deploying serverless. Here you can pick whatever name you want to call it. So in this case, we'll call it RisingWave demo. We'll just create it in AWS. Next option, you can pick within that cluster, you can pick a different location. We'll pick it US East 2. And they'll go ahead and spin up. Now, I don't want to, this process takes 5 to 10 minutes, but I don't want to bore you with this necessarily. You can see these different things and it goes through a deploying mechanism. What I'm going to go ahead and do is jump ahead for purposes of time and go back to one of my existing organizations that I've already spun something up here for RisingWave for the demo. And eventually your instance would come up. So it looks something like this. Your instance name would be here. You'd have a cluster available for you. And if you click on the dashboard, you can start to see different metrics around the cluster, the number of topics, the number of producers and consumers subscribed. You can also see some information on URLs. It's a serverless cluster, what version of the software you're running, etc. And most importantly, different access points, right? This is, again, we support multi-protocol. So if you want to connect using the Pulsar protocol, you use this URL. If you want to use WebSockets, this one. Today for RisingWave, we also, Emily's going to use this URL. I've already handed this off to her, and she has a service account that she can use to connect to that. And if you go to this connect to cluster link here, it will walk you through the steps of step by step, how you want to connect to it. Since she will be using a Python client, you select that language and you do next, pick whichever service account. Emily, again, is for her. She would go down this path. She'd give her a service endpoint. She can choose her different authentication mechanisms, either OAuth 2 or API key. It'd walk you through what libraries you need to install, which particular topic and namespace she's going to publish to or consume from. In this case, this is the one here. So you can see a lot of this stuff is pre-populated for you. Makes it easier for her to just copy and paste a lot of this code and test things out. This is an example producer code. And again, scrolling down, there's example consumer code, and everything is here natively. The URL and everything is put in ahead of time. She can just continue to use this as well as, and just as a good guide for that. You can also see if she goes to the public, we'll go to the namespace of default. There's some existing, obviously, topics there, and look at the topic data. We can also see as we get started that we can keep an eye on how much data is coming in, details around the topic itself, access to schema information, policy around who can access it, produce and consume. So you'd have to go through in this example and give Emily the ability to write and consume from that topic for this demo. And that's really it. It's really ready for her to go at this point in time. And I could just hand it over to her and let her continue to run the demo and connect to it and do some analytics on this Twitter data once she starts generating it. So with that, I will stop sharing and pitch it back to Emily, who can do all the fun stuff now. So thank you.
Thank you. Great. So I'll go ahead and share my screen. So on our end, we'll first start with sending some data to the StreamNative cluster. So I have this Python notebook script that's already. It has all the code needed to generate some data and send it to the StreamNative cluster that David mentioned. You can find a similar version of this script in our blog. Yeah, and if you want to test things out yourself. So I'll be sending it to a new Twitter topic just because the existing one already has some data. I think it'll be better if we can start with a fresh topic that doesn't have anything. And I'll go ahead and send over 1,000 messages. We'll see all those messages being generated. And here's just a rough idea of what each message looks like. You'll have some information on when the tweet was created, the ID of the tweet, the actual content, the language, as well as some information on the author. So it may be a little bit difficult to see here. Right. So once that's ready, you can go ahead and head over to RisingWave or RisingWave.cloud or cloud.risingwave.com. It'll direct you to the same page where you can sign up using Google, your Outlook account, or GitHub. You'll get a free 7-day trial of RisingWave, and that comes with all of the features of RisingWave. The difference is that, or when I say all that extra features, is that when you're deploying RisingWave locally, we have this version called RisingWave Premium that comes with a few additional features such as secret management and like connecting to Snowflake. That's more meant for organizations that are intending to deploy RisingWave in a official environment. And RisingWave Cloud has all of those included where you don't need to access premium necessarily. So once you have RisingWave Cloud set up, I already have logged into my account here. You're going to be met with a page that's somewhat similar to this, where you'll be prompted to create a project. Or if you're already part of an organization, you can invite people or add a new account, as well as the billing for, what plan you're on. If you first signed up, you'll be on the trial plan, again, 7 days for free. Afterwards, you can choose to insert a payment method and continue to use RisingWave. So in this case, let's go ahead and create a project. You can name your project, rename it in this case. We'll go ahead and we'll name it Twitter Demo. And you can choose your service provider, your region, and your compute size. One RWU is approximately 4 gigabytes of RAM. That's how we calculate our RWUs. If you're on a payment plan, you can use more if needed. On a trial version, it'll just be 2. And we can go ahead and confirm that. And as the project is being created, I'll go a little more into what RisingWave is. So RisingWave is a SQL platform for event streaming workloads. You can ingest data from a variety of messaging systems and CDC sources, such as Kafka, Pulsar, Kinesis, or MySQL. So in this case, we'll be using the Kafka connector, but if you prefer Pulsar or even MQTT, which StreamNative also provides, you can use those connectors as well. You can easily deploy RisingWave locally or through here, RisingWave Cloud, which makes database management much easier. So RisingWave Cloud is going to be your ideal solution for managing real-time data sources like your data event streams, or executing complex on-the-fly queries such as big joins, aggregations, time windowing, or if you want to interactively explore consistent up-to-the-date data. There's a lot of other stream processing systems out there. So I'll go over some of the more unique or some of the more standout features of RisingWave. So first, it is Postgres compatible, which is obviously kind of popular in the database space. This makes it easier for everyone to learn how to get started with RisingWave. Again, since it uses SQL, a lot of the SQL functions are very similar, and it uses the Postgres wire protocol. So any other platform where you can connect to Postgres, you can also connect to RisingWave. Another main integral feature is the availability of materialized views. Materialized views maintain up-to-the-date results of a query. So if you're trying to transform your data, join your data, materialized view will consistently maintain those up-to-date results of that. The results are updated whenever new data arrives instead of trying to go back and recalculate everything. RisingWave uses incremental computation so that it's faster and more efficient. And next, RisingWave offers a full set of stream processing features from like time windows, watermarks, temporal filters, and UDFs. So you can define your own functions when the SQL logic isn't able to support whatever transformation you need to perform. And as an event processing platform, RisingWave maintains a wide variety of integrations, so you can ingest and sync data from any platform. You can also connect RisingWave to visualization tools, so it's easy to build out your whole data pipeline. So I know I rambled for a little bit, and the project has been ready for a while, so let's go ahead and click into it. So here's just an overview of what your project has so far. So like your sources, any tables, materialized views, and your throughput for your source. You can create your database user if you need, and if you need the connection string to connect RisingWave elsewhere. Yeah, so on the side, you also have access to these additional tabs that, again, provide you more insight onto what existing connections you have. And if you want to look at your performance metrics, manage your users, stuff like that. But if you want to get started with processing stuff, you can go ahead and head over to the SQL editor tab, or if you're back on this page, it'll be the workspace button. So here you can create anything that you need to start processing data. So your sources, sinks, or you can just run a SQL query as is. Since I have the queries ready, we'll be using that. So in this case, you can choose to create a table or a source when you're ingesting data from, in this case, StreamNative. The difference is that a source just creates that connection between these two clusters, but it doesn't necessarily start ingesting data. In that case, data is only ingested once you create a materialized view. However, when you create a table, that data is going to be persisted in RisingWave, and you can query from it whenever you want. It'll take up a little bit of more storage space, but obviously that's going to be the trade-off. So in this case, we have our data schema. Again, that's just going to be the same as the structure of the messages here. Your tweet created at time, tweet ID, that's going to match with this schema. And then our connector properties, in this case, it's going to be Kafka, your topic, Bootstrap server, your user information, and all of that. And then your startup mode, meaning when do you want to start ingesting data from? So that could be from the beginning, since you're starting from when the cluster was created, or you can do latest starting from when you create the source. So let's go ahead and just quickly query from it so that we can get an idea of what our data looks like. So we'll just query 5 so that we have. All right. So that we can just see what stuff looks like. So again, have your text, your language, your when the tweeter was, when their account was created, stuff like that. And then we can go ahead and create a materialized view. And today for our materialized view, we're going to be analyzing what types of tweet or what types of hashtags people are using in their tweets. So we'll be, I'll go ahead and copy over the query first so that we have something to look at as I talk through it. So we'll be, sorry, seems like I moved the windows a little bit too big. I'll go ahead and refresh the page. But we'll be using the unnest function to extract, or sorry, we'll be using the regexp function to extract the actual hashtags from the tweet using this regex expression, and then this flag indicator, meaning global, that'll extract all hashtag instances rather than just the first one. And then we can use the unnest function to sort of expand whatever we extract from the tweet into its own separate columns. And then that'll be like the first subquery where we're just extracting all of that information. And then from that subquery, we'll be just counting each hashtag occurrence, how many times each hashtag has occurred within a certain time interval using this tumble function. The tumble function will assign each message a certain time window so that we have a window start and window end time, and then we can group by the window start time to see how many times each hashtag was used within that 1 minute interval. I'll go ahead and run that. And then we can select everything from hot hashtags. We can get an idea of, which hashtags are used within which window period. And the window start time, since we know it's going to be within a 1 minute interval, it's implicitly implied that this is going to be between 4:06 and 4:07. And yeah, we can order by hashtag occurrences just to see if any hashtag was particularly popular. Since everything is generated, we can't really get like a trend going on, but we do see that the whatever hashtag has occurred the most out of any other that were used. And after you've created your materialized views, another option that you have is to sync your data back to your StreamNative cluster using a create sync command. I'll just show you what that will look like. So create sync, again, since we're creating a sync, and you can choose what data you want to sync. So it can be a query or just everything from a materialized view or a table. Then we'll specify again your connector parameters. That's going to be pretty much the same as how we created our table. So nothing particularly interesting here, but at the end, you'll also need to specify what format things will be in, and if it's going to be an append only type of sync, in which case every single change made to in this case, your data source will be delivered to our StreamNative cluster, or it can be an upsert type of sync, in which case you need to define a primary key. So I'll go ahead and sync that to a new topic. And you can see it was successfully created. And if we head over to the StreamNative cluster, it should be available for us to see. Yeah, so there's already some messages that were delivered. And I think we can, if we create a subscription, we can look at the messages. Yeah. So it'll be similar to what we saw queried in RisingWave. And of course, once we have all of our sources and our syncs created, we can, on the connector side, on the side tab here, we'll actually be able to see some of this additional information that includes the data schema, what is the primary key, any dependent objects. In this case, we created a materialized view that is dependent on this Twitter table, so it'll be shown here, as well as our sync, which there isn't as much additional information to look at, though it will show you our endpoint and the materialized view, which it'll show you what query was used to create it, the throughput, since our data generator isn't consistently generating data. There isn't necessarily a throughput, though it will show you the row count. Yeah, and then the performance metrics of this cluster as it's processing and ingesting data. And yeah, that is pretty much it for everything on RisingWave's side. We did finish a bit early, but I guess that means more time for questions if anybody has them in the chat. Or if David has anything else to add on his end regards to StreamNative.
Nope. Thank you very much, Emily, for that. That's very instructive. So what you've shown us is that not only can you consume data from Kafka topic, but you could do some analytics in theory, do some processing on it, UDF, some data cleansing, and write it right back. So very, very useful integration. And thank you for showing that. I don't have anything to add. I think you did quite well. I think I'll open it up to questions is the next best thing.
Yep. So if there are any questions, feel free to just like type it in the chat or use Q&A button. If there are no questions, shall we give them some more time?
Give them some time. Let them remember that both of these are available. RisingWave Cloud and StreamNative Cloud are both available for free. It's free to try them out, right? Lots of time to try everything out. We can make the source code is available on the blog that was shared by RisingWave, so you can definitely try it out. Everything it's free to try, and yeah, any other questions they might have, we're glad to answer them. So.
Yes, there is a question. Emily, do you want to read it?
Yeah, so are there any special throttling mechanism for back pressure between Pulsar and RisingWave? So in general, there are ways to sort of mitigate any back pressure issues you have in RisingWave. I don't remember any of the specifics, but if you head over to our docs site, we do have some guides that show you how to solve any back pressure issues you have. Let me see if I can find them. Yeah, we do. So
And then there's another question came up. As far as back pressure is concerned, I can address that one from the Pulsar side. When you produce messages to the broker, an acknowledgement is sent back to the producer of that message to ensure there's an acknowledgement. So if there's any failure on the Pulsar cluster side, for whatever reason, in terms of keeping up with the volume of data, the lack of acts will cause back pressure on the client, which would be RisingWave, and they would moderate and catch all that data. So that's how the mechanism is implemented from that integration standpoint. The second question was, can I call out to AI models to do any sentiment analysis on the Twitter feeds? I can answer that. Take a first stab at it, and I'll let Emily have a second pass at it. There is something within Pulsar called Pulsar Functions. It's a lightweight compute framework that allows you to write code. We have some demos out there where you can use existing tools that do sentiment analysis on tweets that would read the text of a tweet, run it through a sentiment analysis, and assign a negative or positive score to it. That's something you could do within the platform itself, and then publish the results in an augmented tweet stream. That's one approach within our platform. I'm sure RisingWave might have a way to solve that problem as well, and I'll let Emily handle that as well.
Yeah, I think in that case, the best solution to that, or the best method for that, would be UDFs. RisingWave currently supports both external and internal UDFs. So internal UDFs just means that you're going to be defining your UDFs in whatever language you choose within RisingWave. That is a little bit limited because you don't have any access to external libraries. However, if you do use external UDFs, you can define them locally in your own project. And in that case, you can use whatever machine learning library is out there to perform sentiment analysis or to create your own ML algorithm for more complex data process or language processing. And you can load that function into RisingWave and then use it within RisingWave on the incoming data. There is obviously going to be a little bit of performance issue in that because it's going to be dependent on how fast your algorithm can perform. And that's probably going to be a lot slower than how fast data is coming in.
Okay.
Hey, we got a thumbs up. That's great. Yeah, thank you for that, Emily. So.
Okay, it seems that that's all for today. Thank you both Emily and David. Thank you everybody who joined today, and see you soon.
Thank you. Have a great day.
Thanks, everyone. Bye.
Bye.